Hello friends, this is JBrains again. In this video we're going to implement the add fractions feature in Java. We're going to focus on microsteps and high discipline test-driven development. This is going to be some more fundamentals, the kinds of things that we forget to do from time to time, but whenever I get into a little bit of trouble, I find that following these microsteps really calms me down, gets me focused, and gets me back on doing good work. Now, we're going to continue from where we left off with our Java environment. And the very first thing, of course, that we're going to do is write a test. So I'm going to create a new test class. And I'm going to call this, let's see here. Again, we're using the standard naming convention for Java packages. We're putting our tests in a package called test. I've decided to call the project math because fractions kind of sounds like they belong in a math library. That would sort of be is the kind of thing that I would submit to Java as a standard extension if I were that industrious, but I'm not. And I'm going to name the test class not after the class I'm testing, but after the behavior I'm implementing. This way, I'm not locking myself into decisions about how to structure the solution. So rather than calling this fraction test, which I'm sure a lot of people out there would probably have the impulse to do, I'm going to call this add fractions test. Unsurprising. All right, now, in order to write these tests, let's consult our test list over here. And remember that our kernel was the simplest test we could possibly think of, which was the case where 0 plus 0 equals 0. So I'm going to start there. Now, in naming the test method, while I'm naming the test class after the behavior I'm implementing, this is the kind of behavior that has a whole bunch of different special cases. You can see that over here on a test list, right? There's about 10 or 15 different special cases that we need to think about. And so when I'm faced with this kind of behavior, where there's one behavior and a bunch of different, or one operation and a bunch of different special cases, then I name the test class after the operation, and the test methods are each named after a special case. Now, I don't really know what makes this first special case special, and so if I can't give it a name that represents the why, then at least I can give it a name that represents the what. And in this case, it's 0 plus 0, which will give us some clue about how to implement the test. The next micro technique that I use is writing the assertion first. The idea of writing the test backwards, starting with the assertion, then working backwards, kind of helps me avoid copying and pasting fluff into my test. So I'm going to write the assertion first and then figure out how to work backwards to everything I need in order to make that test run. And I'm going to do this in painstaking detail, so I apologize. Now, the first thing I need to know is that in this particular test, the expected result is 0, and that's the sum of the two fractions. Now, the question is, where does this sum come from? Well, the sum comes from adding two fractions together. So I'm going to create a fraction that represents 0. I'm going to add it to another fraction that represents 0, and I'm going to... I can't assign that to a value because we don't know what the expression type is, but I know that the sum is going to be a fraction. So I'll just enter that in. And right away we have a problem. Even if I import assert equals, the problem we have now is that I can't compare sum, which is a fraction object, to 0, which is an int. Now, of course, sum needs to be a fraction object because I'm going to implement this as a whole value. And the way that whole values generally work, you have a class that represents the value, and operations that combine those objects of those class into a new value return a new instance of that object. So we know that plus should return a new fraction, but I can't compare fraction to 0. So what can I do? Well, there's two things that I can think of. One of them is to implement the equals method so that I have this working. So if I have a fraction equals working, then I'll be able to use that to test drive add. The other option would be to implement some kind of scaffolding, something that allows me to check the internal state of fraction, something that I generally don't like to do, but some way that I can inquire about the state of fraction so that I can at least check the result as I go. Now, in weighing these two options, I want to err on the side of safety, and it seems really premature at this point to implement equals on fractions since I haven't even created any fields on it yet. And if I want to focus on implementing add, then I'd like to focus on implementing add. I know that's a tautological statement, but it really boils down to I don't want implementing equals to distract me from implementing add. And I don't want to make a mistake in equals that causes me to make a mistake in add. So what I'm going to do is I'm going to choose the second option. I'm actually going to create a little bit of scaffolding that allows me to check that plus does the right thing without having to implement equals. And then over here on my test list, I'm going to add up here in the corner equals to remind me that I need to implement equals. Now, the sooner I get to being able to use equals to check add, the happier I'll be. But in the meantime, I got to do what I got to do. So in order to make this work, I need to ask the sum for its value as an integer. Now, I'm not going to make the fraction behave like an actual number object in Java, but since the number hierarchy is there and it's a well-known, well-understood part of Java, I think it's a good idea to use the naming conventions that are built into Java, the ones that Java programmers are familiar with. So if you don't know what to name something and there's an existing well-known convention that you can conform to that you don't hate, then I'd say go for it. And that means asking sum for its int value, which is exactly how you try to turn any Java number into an int. So now I've written my entire test. I can take one more look at the test and ask the question, does this suck? And I think it works out pretty well. I'm a little surprised that I ended up naming the method plus instead of add. I mean, the class name of the test is add fractions test. We think about adding fractions. And yet when I wrote the code, plus felt more natural. So I'm going to leave it like this for now. I know that contradicts what I just said about the existing naming convention. These are judgment calls. If you're really unsure, and if you and I were pairing and you were really uncomfortable with calling this plus, I'd switch it to add. But since I'm the only one at the keyboard right now, I'm going to call it plus. So now this test, I think it has everything it needs. Let's generate some code so that we can run the test and watch it fail. So we're going to create a fraction class. I'm going to put that in the production package, so without the word test on it. I'm going to put it in the production source tree. And let's call the parameter something a little better than I. All right, now let's go back here. We need a plus method. And we'll return null for now. I'm not usually a big fan of that, but it'll get us going. And then int value will return int. Returning 0 is okay. In this case, it will happen to conveniently already pass, so let's just put a value in there that won't conveniently pass. We have now enough to run our test, so let's run the test. And we get a null pointer exception, and that null pointer is here. Sum is null, so let's change plus so that it doesn't return null. The simplest thing I can think of to return is either one of the two fractions. That test passes now for a more interesting reason. I expected 0, but got negative 23,764. Well, fake it till you make it. Now the test passes, and we can move on to the next step. So I'm just going to scratch off this test, flip over here. Let's look at our differences. We have this new class called fraction. We have this new class called add fractions test, so the diff is a little boring. We now add 0 to 0. Doesn't sound like much, but it's a start. And now for our next test. Now, which test should I choose next? Looking over our test list, we have few possibilities around here. I think the easiest tests are the ones where we're adding something that's not 0 to 0. So arbitrarily, I'm going to choose 3 plus 0 equals 3. I'm going to call this non-zero plus 0. It's a little closer to, I could call it 3 plus 0, but I don't know what the 3 really signifies, or I do know what the 3 really signifies. Something that's not 0. So let's start again. I'm going to do this the somewhat long way. Start with my assertion. The sum's integer value should be 3, and it's 3 because we are adding 3 plus 0. And that's sum. The tests, we don't have to generate any new code to make the test run, so let's run it and watch it fail. Expected 3 but got 0. And now in order to make it pass, I'd love to be able to just hard code 0 or 3 here in int value, but I can't. The good news is, however, that I do see that since plus is returning this every single time, by coincidence over here, this int value in the test is 0 and the sum int value should be 0. And in the second test, this int value is 3 and sum's int value should be 3. So it sounds like the sum is this, but the object fraction isn't remembering its value. Well, that's an easy change. Let's store that, and then let's return it. And both tests should pass, and they do. So we'll go back over to our test list. We'll cross off 3 plus 0 equals 3, and check everything in. The diff should be slightly more interesting now. We have replaced return 0 with return integer value, and then we're now storing the integer value, and of course we just have our new test. And we now add non-zero to 0. Well, the next test is pretty obvious to me. Zero plus non-zero. That's 0 plus 5, so the result should be 5. All right, let's run that test and watch it fail. And now let's figure out how to make it pass. Now, so far, it looks like we get the integer value. We probably get that correct. So the 5 is being stored, but the 5 is over here in that. And we're just returning this. Now, I could write a little code that says, well, if that integer value is greater than 0, then return it. Otherwise, return this. That seems like it's going a little bit too far. If I wasn't 100% sure of the next step, then I would do that. I would in fact go, if that integer value is not 0, then return that. In fact, let's just see if this works. Why not? We're taking micro steps, aren't we? That happens to pass. Now, it's ugly, but it emphasizes, and in fact, I strongly prefer doing it this way just for symmetry. So let's run that test. And in fact, you know what? I'm gonna call that test passing. So over here on my test list, I'm gonna scratch out 0 plus 5 equals 5. And I'm gonna check it in. Remember, we're working on micro steps here. See, we now add 0 to non-zero. Now that looks weird. And if I didn't already know the next step, in a real life situation where we're pairing on real code and we're getting paid to do it, I wouldn't bother taking this step. I'm taking this step really for teaching purposes to show that in a situation where maybe you're not 100% sure what the next step is, this is a micro step that will push you in that direction. So when you're about to pass a test that forces you to generalize code and you're not 100% comfortable with that the new algorithm, the thing that the generalizing you're doing is going to be correct, then the simplest thing to do is add an if statement for the new case, else do the old thing, and get that working first. And now we can much more safely try the obvious implementation, and we can back it out right away if it doesn't work, and we're back to passing code. If I had, let's say that I had just entered the obvious implementation straight away and it didn't work, then when I backed it out, I'd have to back it out to failing code. And it's really dangerous to go from failing code to other failing code, because you can't be 100% sure that the failing code that you have now is failing for the same reasons as the code you had 5 minutes ago. It's much easier to get quickly to the point where you have a passing test, then experiment with something, and if it fails, you get to fall back to the passing tests. This is what's known as the ratchet effect. The idea that the ratchet stops the gear from falling back too far. It grabs on and holds on to you. My good friend Patrick Wilson Welsh always talked about the rock climbing metaphor, right? You nail pitons into the side of the rock, so that you can only fall so far when you fall. And one of the micro techniques in test-driven development is to write code in such a way that minimizes the cost of your mistakes, even if it requires some extra steps. One thing I can tell you from definite experience is the cost of the extra steps, if you do them well in a disciplined manner and practice them, is much smaller than the cost of making unexpected mistakes. All right, enough talking, back to some code. Let's write our next tests. Going back over to our test list, the obvious next step would be to try 3 plus 4 equals 7. At least it's still just positive numbers, but neither one of them is 0. So let's try that. And that's interesting that none of our tests so far have actually talked about positive and negative, so maybe we're going to have to worry about that. But at any rate, non-negative integer, non-negative non-zero operands. Okay, test name's starting to get a little unwieldy, but you know, it's math. Terms in math are unwieldy. So the result should be 7. And that comes from 3 plus 4. Whoops. And that is again our sum. Nothing new to compile. Run the test. Watch it fail. We should probably get 4 or 3. I'm not sure which. We ended up getting 4 instead of 7. And now we can see an example of how to replace an old implementation with a new one. This is a really simple refactoring. What I'm going to do is I'm going to use the same microstep as before. Actually, no, I'm not going to use the same microstep as before. I'm going to try the obvious implementation and see what happens. So the integer value on the right-hand side is definitely not 0. So this is the case that I want to work on. And I'm going to try replacing this with the obvious implementation. I know that this dot integer value is not strictly speaking needed, but I like the symmetry of this integer value plus that integer value. So I've just added the obvious implementation. Let's see if it works. It does, so I'm going to go back to my test list, cross off the tests, and check this in. We now add non-zero, non-negative integers. What I'd like to do now is get rid of some of the funkiness in our code. This seems excessive. I get the sense that this implementation, this new fraction code, is going to work for both cases, so I'm just going to copy it down and try it. So notice the microstep here. I didn't remove the if statement. If I think I can remove an if statement, the first step is copy one of the bodies to another one and see if that works. And then to the third one, the fourth one, the fifth one. And when they're all identical, then I can remove the if statement. So that passed. So now let's try. Well, now we don't have to try this. We're guaranteed it's going to work, but we're going to run the tests anyway. And they pass. So, let's see, removed obsolete code. That's really what it looks like. If we look at this diff, we see that we've actually replaced an if statement with something simpler. So what we've done really is removed obsolete code. All right, now going back to our test list for a moment, we have 2 more tests for the integer case, but I have a feeling that I look at these tests and I think they're already going to pass. Now, there's a principle in test-driven development that I like to follow. That is, I only write tests that force me to contemplate or change the design. And I don't like to write tests that I already know won't do that. Now, since we're focusing on microsteps, I might just write both these tests for the sake of completion. It'll only take 30 seconds and it's not a big deal. But just to talk about what I might do in a real-life industrial situation and you and I were pairing, I would say let's skip these 2 tests. And if that made you slightly uncomfortable, then I would say fine. Let's go to the most complicated of those two tests and just implement that one. And to me, the more complicated one is the one with two negative signs instead of just one. So I'm going to try -3 plus 1 equals -2. So again, the result should be -2. And I've done this enough that you'd think I would want to copy and paste. And the only reason I let myself get away with copying and pasting here is because I'm copying and pasting very little. What I definitely want to avoid is copying and pasting these long, crazy setups into additional tests. We're going to come back to that problem later. That's the kind of copy and paste that drives me nuts. The test already compiles, so let's run it. It should already pass, and it does. So I'll go back to the test list, and I'll cross that off. And let's see, we now add negative integers even when it gives us a negative result. So again, that test already passed. If I were the slightest bit concerned, if you were the slightest bit concerned and we were pairing together, then we would just go into plus and, I don't know, change something to try to make the test fail. And we made a whole bunch of tests fail. In fact, we made them all fail. Congratulations. So we know for sure that that test is actually testing something. Well, we have more confidence that test is testing something. And testing what we think it's testing. Or, as Michael Bolton would have us say, checking what we think is checking. All right, well, I want to pause here. Let's take a look at what we've got. We've written a handful of tests here that correspond to 6 of the tests over here on our test list. I'm going to do nothing with this -5 plus 8 test. At the end, when I think the add fractions feature is done, if we have some tests left over, then I'll just decide I'll cross them out anyway because I don't think we need to deal with it. I could cross it out now, but I'm not going to. I'm just going to leave it there as a reminder that I haven't implemented that. Up here in the upper right-hand corner, I've just jotted down equals as something that we're going to have to do. So we'll come back to that in a little bit. And I just want to look at the duplication in our tests here. I don't think there's anything I can really do about this duplication. I suppose what I could do is inline all these variables. So let's just see. This is one of those, questions of taste. So if you and I were pairing, then I would inline a few of these and I would show them on the screen like this and ask you, which one do you like more? Do you like the version where we have new fraction plus new fraction int value all on one line, or where we have the temporary variable sum? We could remove the duplication in an incredibly crazy way. Add fractions, then extract int value. And then we're going to have to add the parameters back. So let's see. Parameter add end as int. I don't like this already, but let's see what we end up with. Augend as int. All right, so now we have 3 choices. Let's just move this out of the way for the moment. Now we have 3 choices. We can write the test like this over here on line 16, like this over here on line 21, or keep the old version, the old format that we've been using here on lines 30 and 31. I would definitely put this extracted version for now. I would put this extracted version at the bottom of the list, which sounds strange, only because I find it a little bit difficult to read. I feel comfortable doing it all on one line, but if you wanted to keep it on 2 lines, that would be okay too. So let's just back out this last crazy change. And I'm going to put these all on one, I'm going to put these all on one line just because I think it's a little bit easier to read. And in fact, the The duplication in here is another reminder that this int value thing needs to go. And we know that we want to replace that eventually with equals. But we just don't want to implement equals just yet. So I'll run the tests one more time, make sure they still pass. Let's check our diff. All right, so shortened tests by inlining temporary variables. Now they're all nice little one-liners that I find relatively easy to read. And where we'll go from here, well, that's the subject of the next video. So I hope you enjoyed it.